Great. Thank you, Ty. Thanks for everybody for showing up, or thanks everybody for showing up this morning on this cold day. We've got people from a lot of different states on the call, I know, and appreciate you all taking the time to join us. It's our goal. It's always our goal to provide valuable information to our customers. So we sincerely hope you get something of use today. And if you have ideas for future conferences of things that you'd like to hear addressed, please email us and let us know, because we're always looking for new ideas. We used to always hold these in person, and there's a real value in that to all get together and share a meal. But we've found out over the years that holding these virtually actually works pretty well, because we have so many customers scattered around the country, and it's a way for us to involve people from all over the United States. Rather than just the small local area, plus obviously sometimes travel in the wintertime and stuff. So again, thanks for coming today. And as Ty already said, thanks to all the people here at Lea Seed that made this event happen. That'd be Cole Thompson, Randy Harmdirks, Ashley Bingham, Margaret Smith, Ilya Romano, Denise Hoffman, and probably somebody else that I'm not naming. So thanks to all those folks. That's me there on the left. If you can see my slides, holding up a little packet of corn seeds and pretending to be a corn researcher, which I'm not. But that's me actually I think that's May, down in Kelly, Iowa. And for those of you who don't know me, so again, my name is Mac Ehrhardt, currently chairman of Lea Seed. Worked here for about 33 years now. Grew up in this business, worked with my dad and my brother. And I stepped back from the presidency role last year, and we hired a new president and CEO, Brett Bell. And he's pictured there in that picture on the right. He's the guy in the light blue shirt and the Blue River hat. And Brett joined us in August and has hit the ground running and has really been a nice fit for our company. And we're glad to have him on our team. Standing next to Brett in that picture, and it's relevant to this presentation, is Scott Johnson. He's been a corn breeder for more than 30 years, and he's the head of research and development for this corn breeding program that we've invested in. And then standing next to Scott there, the tall guy, that's Jake Hansen, who many of you know. He's our product manager for the Blue River and Viking corn and soybean brands. Jake, if you look closely, you can see in his right hand, he's holding an ear of blue corn. And that's significant because the three of them are standing in front of a nursery plot of some new pure maize inbreds. And that blue ear of corn is something that we use to identify when the pure maize trait is working and when it's not. So Scott was trying to explain to us laymen how that whole process works, and it's quite complicated. And don't worry, I'm not going to lecture you about it today. So again, thanks for being here. I'm going to jump ahead. If I could have the next slide. All right, so what I'm going to talk about today is kind of an investment that we made into corn research, directly into corn breeding and corn research last August. And to do that, I'm going to talk also a little bit about the current state of corn research in the United States and around the world. I'm going to talk about our program, the who, what, where, why part of it, some of our goals. And then if I have time, my half an hour or so, I'm going to touch a little bit on some other research areas, not directly related to corn breeding and corn research, but having to do with other things. So if I could have the next slide, please. All right, so this is the announcement. I think somebody on the internet had teased this as a big announcement, and it's not that big of an announcement. We've been talking about it for a little while, but it's a big deal for us, and I firmly believe it's an important step for not only us but for our customers. So what have we done? We've invested in a corn breeding and research program, and that image there also I want to mention is a real image. That's not a stock photography image. That's a picture of we're planting some experimental seed corn there in May of 2023 down in Kelly, Iowa. So that's us in action already last summer. Even though we didn't close on the deal until August, the research had been going on for 20 years, and this was just a continuation of that project. So who's involved? So Lea Seed House is an investor, and we're partnering with some other corn researchers based there in Kelly, Iowa, and one of them is based in Southern Illinois. And these are folks, some of whom have been, as I mentioned already, breeding corn for over 30 years, and some of them are more recent additions, but they're all experienced corn researchers. And we bought the location there in Kelly, Iowa, the research facility, the buildings, the cleaning plant, the packetizing plant, a walking and a cold storage room for all the small samples of seed that we have. Bought an acreage there, and the staff is now working for this joint venture, and it's based in Kelly, Iowa, again, and Springfield, Illinois. So where did these genetics come from? So these genetics that we're working with are largely sourced from a program that's been in force, that's been running for over 20 years, and breeding new corn inbreds in order to produce hybrids. And these inbreds have been successfully integrated into the Viking brand and Blue River brand in the past. They've also been out licensed to other companies in the corn industry. So this is an established breeding program. This is not a brand new thing that we're just starting up from scratch. We have a well-established breeding program that has a history of producing inbreds that have good general combining ability and are licensed by other programs. And so the last question I put there is sort of the why, and I want to talk about that over the next couple slides. Why did we make this investment? Ty, if I could have the next slide, please. So this slide, I think, goes a long way toward explaining the why. So I think everybody on this call and everybody in agriculture understands that there's been a lot of consolidation in ag over the last 30 years. I think when you look at the actual numbers involved, it's a little startling in that 95% of all the corn intellectual property and germplasm in the United States is owned by 4 companies. And I've put up their logos on this slide. And this is not just a guess on my part, by the way. You can see there's a source for this on the bottom. This is a well-researched report put out by the USDA in March of 2023. And I think everybody kind of recognizes the names here. Corteva obviously owns Pioneer. Bayer, which now owns Monsanto, has some major brands in the U.S. and the DeKalb brand and all the channel brands. And then Syngenta has been a large player in the corn space in the past, and they got purchased by ChemChina. And then the last one, BASF, which is probably of those one of the smaller corn genetic, has probably the smallest position in intellectual property in corn in the U.S., but still is a big player. So 95% of all the corn intellectual property and germplasm is owned by these 4 companies. I think it's sort of implicit to most of the people on this call why that is probably not a great thing for organic farmers. And I want to talk more about that. So if I could have the next slide, please. So specifically, why do I think this is a problem? And this is one of the reasons why Lea Seed has made this investment, right? So first and foremost, these companies don't really have a strong interest in organic corn production or organic farming in general. They may not be openly hostile to it, but as a market, it's a very small segment of the acres, and it's not something that they're going to focus their breeding programs on or spend any time thinking about. And as a result, they make of the inbreds that they make available to the industry for licensing that allow us to produce hybrid seed, there's very limited availability of untreated inbred seed. And so that doesn't mean that we don't license some good hybrids that have come out of these companies, that we certainly have, but there's very limited quantities of it available, and it's what I would call sort of a narrow bandwidth. And this, I think, is a potentially a problem for organic farmers, and it has certainly been in the past and will potentially be in the future, in that there's just a narrow pool of choices to choose from. And I think that's not a good thing. We need a broad diversity of germplasm for organic farmers. Also, these companies have strong breeding restrictions on all of their germplasm. Most of their germplasm is covered under utility patents, and utility patents are very restrictive around corn breeders' ability to use that germplasm in order to breed with. And so it doesn't, you're basically allowed, if they allow you to use them at all, it's usually to cross them with another inbred that's licensed to you and produced one hybrid, and that's basically all you're allowed to do. I think everybody understands also that these companies are primarily aimed at selling traits, and in the past that's been the so-called GMOs, or genetically modified traits, like Roundup Ready corn and BT corn. And that's changing, of course, because these companies are now, a lot of them, already using gene editing to produce novel traits and new new inbreds as well. There are currently some gene edited products in the marketplace, and that breeding is largely not, that type of breeding is largely not going to be allowed in organic agriculture, at least according to what the NOSB is saying right now. Most of the novel breeding techniques, including things like CRISPR-Cas9, gene shuffling, gene silencing, these things are not going to be allowed on organic farms. And so I think it's another issue potentially in the future for organic farmers who, when all of this germplasm is owned by these companies that are using these technologies. And then finally, and probably the one that's least interesting to the folks on this call until you have to pay for your seed corn, is the royalty structure. And what we have seen over the last 10 or 20 years, no surprise, is royalties for any germplasm that we in-license from these large companies. The royalties keep getting more and more expensive, and that's causing significant pain in the seed industry. Okay, next slide, please. One thing I didn't say at the beginning, and I should have said, if you have a question while I'm going through this, and I welcome questions, please put your questions in the chat, and then Ty will interrupt me and tell me that somebody has a question, and I'll try to do my best to answer it. Here are some more reasons why we invested in this breeding program. I think that again, I think the ownership of 95% of the germplasm by these 4 companies presents a problem because their research programs are really not aligned with the needs of organic farmers. Almost all of their product selection is happening under very intensely managed acres. Some people call it ice cream ground. So it's just nice, deep black soils, planted at very high populations, fertilized heavily. And then, of course, they can use herbicides and fungicides to control herbicides to control weeds, fungicides to control diseases, also insecticides. And I think one of the most important features here is that almost all the seed that they're planting, of course, is treated with fungicides and insecticides. And I think this is a real structural problem in those research programs, at least as far as organic farmers are concerned, because fungicides and insecticides are not tools that organic farmers can use, obviously. And so by virtue of having all of the seed in their research programs coated with fungicides and insecticides, they are never selecting for the kind of emergence that organic farmers need. They aren't. And I think everybody that plants organic corn understands how essential it is that we get fast emergence and good speed to canopy. And if if these breeding programs are planting all of their trials and all of their research plots with seed coated with these fungicides and insecticides, they're never giving us the selection pressure we need to identify inbreds and hybrids with the kind of emergence that organic farmers need. So I think that's a real structural problem for these, at least as far as organic farmers are concerned. And then, as I mentioned already, there's basically no weed pressure. Let's see here, I'm moving my screen around a little bit. So that, I think, hopefully answers the why for the people on this call. Why did we invest in this corn breeding and research effort, which is a significant investment for us in the long-term success of our company for our customers, right? So this, again, like almost everything we do, we try to think about our customers first. And if this is something that we believe our customers need over the long haul, we're going to make an investment to make it happen. And so we are going to be breeding for organic farmers and for farmers who use non-GMO hybrids as well. We're going to maintain our independence with a breeding program that is not reliant on genetics from other companies. Now, I want to be clear that we still are going to be testing hybrids that are coming from other companies, the large companies and the small companies. We're going to be working with those hybrids and some of the inbreds that they allow us to make crosses with and even do breeding with. So we're not going to exclusively use this pool of germplasm, but we think it's really important to have this independent pool of germplasm. Also, by having control of the research program and also the ability to produce our own inbred and hybrid, or our own inbred seed and our own hybrid test seed, it's a really reliable source of untreated inbreds for us that we can count on. And also, it's a place where we can be in control of seed purity, and by seed purity, I mean the adventitious presence of GMO in the seed itself. And we very much understand how important seed purity is to organic farmers when they're trying to sell their grain. and we've, Blue River historically has had the Pure Maize program. Viking had the Ultra Pure and Pure programs, and we're going forward with those 3 programs. And without a reliable source of very low, without a reliable source of inbreds that contain a very low level of GMO, it's impossible to produce seed that will that you can plant with confidence. So that's an important factor for us as well. All right. Next slide, please. So what are our breeding goals in this program? And again, this part is really just around the corn breeding aspect of the program. Again, it's 100% non-GMO. All the breeding we're going to be doing is going to be with non-GMO inbreds and non-GMO hybrids. We will not be utilizing any form of restricted gene editing, so no techniques that are restricted by the National Organic Standards Board will be in use. And we'll be breeding directly, really with organic farmers in mind. So number one, there is emergence, right? We get it. That's always when we talk to when we've done this, we've surveyed our growers, we've surveyed dealers, and every single time we talk, that 85 to 90% of people say emergence is number one. Because without a good stand of corn, you just can't get maximum yield. It also leads to, obviously, to problems with weed control. So getting that corn out of the ground, getting it to canopy quickly with a nice broad canopy that shades the row is super important, and those are going to be characteristics we're breeding for every day. Yield obviously matters, and so we get that, and it's not number one, but it's right up there because that's how you make a living, that's how you pay the rent, is with the yield, and so that of course matters a lot. We also will be breeding to produce hybrids that have good ear flex, and that allows the ear to get a little bit, to put on more kernel rows or sometimes get longer if the corn is in a situation where it has a less than ideal stand. So let's say there's some cultivator blight or there was an emergence problem due to insects. The plant has the ability to put on a slightly larger ear to make up for the lower population. That's something we're breeding towards all the time. We'd like to breed for broad adaptability to different soil types, different populations. We obviously are looking for disease tolerant inbreds and hybrids, and that's a strong feature, frankly, of this breeding program. They have very disease tolerant inbreds, and over the years that's been proven out. Also, what we now are starting to call abiotic stress tolerance, which is, we have extreme variability in weather, as I don't think anybody, whether whether you subscribe to climate change or not, I don't think there's anybody that will deny that we have extreme weather variability, and this is going to not get easier, frankly. And so for drought, for heat, for rain, for wind events, we need to be breeding inbreds and hybrids that can stand variable weather. And then finally, we definitely will be searching throughout the program and making crosses from other programs to bring in some hybrids with good grain quality. And by that, I mean grain quality that could meet a food grade contract. All right. Any questions so far, Ty? I guess not.
Yeah, we got one. Sorry, Mac. Yeah, we got
Okay.
one. I don't know if you're gonna be talking about this later on, but someone had a question on, is this initiative is great, but will Alberley Seed be doing something similar with other crops? Do you see it now in the near future, or is it kind of just trying to see how this corn does and maybe expand later on?
Yeah, great question. So I've yet to win the lottery, and breeding is very, very expensive. So we are actually flirting with the idea of working on particular aspect of small grain breeding, and I won't go into it right now, but we strongly believe that not only for organic farmers, but for any farmer that wants to farm using a rotation, having good oat varieties is essential. And as much as we love the work that's being done at some of the universities, let's face it, most of the university oat breeding programs have been closed down. So we have a strong interest in figuring out a way to either partner with someone or work out a way to work on oat breeding for our organic farmers and for conventional farmers wanting to farm with a rotation. So that's probably the first place I would look, and we definitely would not rule it out in other areas in the future. We have in the past funded some breeding efforts. In soybeans, we funded a program to breed for aphid-tolerant soybeans, for example, but we've never actually had an ownership position in one of these research efforts. But I definitely would, in the future, that is our goal to be basic and this kind of research that will help our customers in the organic farming community. Thanks for the question. So what does this actually mean? What are we really working on? This, by the way, is a photo from last May when we're planting a research plot in Cali, Iowa. 8-row planter. Those folks are sitting up there dumping those little packets of experimental hybrids and planting replicated testing for us to test our new stuff against existing hybrids. So right now in Chile, we've got a winter nursery. We're generating new inbreds. We're increasing inbred seed of certain inbreds we're interested in. We're making seed of experimental hybrid crosses that no one has ever seen before, right? So we're taking an inbred that we own and crossing it with another inbred that we own, or we're maybe taking an inbred that we own and crossing it with an inbred that we have the right to work with because we've licensed it from another company. And we're also taking inbreds that we own and crossing them with off-patent inbreds. And we're not doing a lot of that, frankly. I know there's many companies out there working with off-patent material, and there's some interesting things. We think just based on the experience of the folks in this program who've been some of whom have been working on this for 30 years, there is limited success in bringing a 25-year-old inbred into a program and thinking it's going to add yield and be able to compete with a modern inbred. It just hasn't proven out that that's been a very fruitful area of research. Now, that doesn't mean that there aren't particular inbreds that bring interesting things, like I've already talked about. Possibly it's emergence that we're bringing in, maybe it's resistance to a certain disease, or maybe it's grain quality. So we are working with some off-patent inbreds, but the majority of the work we're doing is with inbreds that we already own or have developed ourselves, and inbreds that we're licensing in from other companies. We're also making pre-commercial hybrid seed because we need, every cycle we have to make more seed of the hybrids that we want to test, or if we want to strip trial them, we have to make even more seed. So that's a constant source of work as well. And then for those of you who know pure maize, and I won't talk about it a lot today, we are continuing the pure maize nursery work. We're hoping to launch 2 new pure maize inbreds within the next 18 months that will allow us to make some new earlier pure maize hybrids. In the summer nursery, this next summer now, we'll be doing all those same things, and then we'll also have some observation blocks where we have the ability to go out and look at these all these crosses, including the pure maize crosses, in larger blocks to see how they're performing. Next slide, please. And in addition to all the nursery work, of course, a breeding program is only as good as its testing network, right? Because if you're producing inbreds, that's great, and you're making hybrids, that's great. But if you're not trialing them and bringing them and comparing them to the best available hybrids that your customers have access to, you're not keeping yourself honest. And so these research plots that we do every summer, and we've been doing these, by the way, on a contract basis. The Viking and Blue River brands Blue River's been doing it since it's started, and Viking has been doing research plots to test its new experimentals for the last 15 years or so. This again now is owned by us, and we also have co-op trials with other companies around the country. So these replicated yield trials, we have 3 levels of them. The level 100 trials are new hybrids that no one's ever seen before that we've made either in the winter or in the summer. And again, these could be combinations of our own material crossed with something we've licensed in from another company, or possibly some off-patent material as well. The level and what these level 100 trials are really doing is they're just screening out, okay, does it look like corn? Does it have good roots? Does it have good stalks? Is it competitive yielding? And if they show us all those things and they look interesting, then they make it to the level 200 trial the next year, which is we call the product development trials. Those are 4-row trials. They're over a larger geography with more replications and more locations. And it's just a second look at the things that have made it out of the first level of testing. And then the level 300 trials are the pre-commercial trials that we've been running ourselves for many years. And those are all 4-row. This last summer, we had 5 maturities in pre-commercial testing in 15 states, 55 locations. And those contain experimentals that we think have a good chance of being launched. They also contain experimentals from other companies that we're interested in licensing and selling. And then, of course, they contain commercial checks, and those could be checks from a DeKalb or a Pioneer or a smaller company that is a competitor of ours. And we wanted to make sure that we're competing with the best available germplasm. I think I'll skip over the stuff on the bottom and keep going. That's just kind of reiterating what I've already said. Next slide, please. There you go. This is a snapshot.
We do have a couple questions if Mac has a chance to answer them.
Yeah, I'm good. Go ahead.
All right, yeah. Yeah, so this is from Tom. He said he apologized he wasn't fast enough to unmute it, but he said that since you said that research is very expensive, has any work been done to set up a research fund that would allow growers to invest funds, possibly a separate entity that might allow such return to investors?
Yeah, I like that idea a lot. And there'd be so no, I haven't had anybody introduce that idea before, and thanks for the creative idea. I think that's something we'll definitely consider. I can hear, I'm sitting in my office, and behind me I've got my boss, Brett Bell, our new president and CEO, and I heard him say, wow, that's a great idea. So he's writing it down right now. So thanks for the idea, Tom. The other thing I'm going to talk about here at the if I have time here at the end is there's another sort of co-op testing that we're interested in developing over the next few years, and that would be on-farm strip trials, where we would develop the ability to come on to a cooperator's farm, plant probably 4 to as many as 16 hybrids, but importantly, plant them in a pattern that the local cooperator could do weed control in. So it has to match the cooperator's equipment, obviously, but it would allow us to get a real good look at how these hybrids are performing on organic farms in all these different regions, and get these cooperators a look at how our newest experimentals are doing versus the competitive checks. And this would not be randomized replicated testing, which frankly we tried to start doing that on organic farms several years back, and we just had too many issues with variability in fertility and weed control, and we couldn't get good, consistent scientific data off of it. And so we think going to this strip trial model has a lot of promise, and that would be another way where some of the costs could be borne by the local cooperators, but they would have the benefit of getting of seeing these new products on their farm. So thanks again for the idea. What's the other question?
Have you done any selection with nitrogen use efficiency in the corn breeding program?
Yeah, we have not done selection for that. And so there certainly are corn researchers that have worked on that, and from two angles, frankly. So there's corn breeding itself. So there definitely are differences in hybrids and differences in the ability of certain inbreds to confer nitrogen use efficiency. And there are people that have also worked, obviously, with even trying to get corn plants to be able to fix their own nitrogen. We have not done any direct work on that. It's certainly something that's on the table for us to talk about. This is a small research program, and we don't want to try to do everything. We want to remain very focused so that we don't lose that focus and not accomplish our primary goal, which is coming up with the best hybrids for our customers, right? But that's definitely something that's on the table. It's also important to note that there's another approach to that, which has to do with seed coatings and biologicals, and I'm going to talk more about that here at the end. But we absolutely believe, and it's been proven out, that there are biologicals available that improve nitrogen use efficiency, and those could be extremely useful for organic farmers as well. So great question.
All right, well, that sounds interesting and enticing, so let's keep this show going.
Okay, so I intended to finish at 10, but because the next speaker doesn't start till 10:30, I think I'll just barge ahead, and you guys can cut me off when everybody's sick of hearing me talk. So here, what we're looking at right here is just all of the locations where we had our own plots last summer. And so this is summer 2023. These are all of our replicated locations. These aren't strip plots. These aren't on-farm trials. These are actual replicated plots that we put in last summer and got data off of. It's also important to note we have a lot more locations than this that we get data from, but they're not ones that we control. So we have data coming from the Pacific Northwest and California and even Texas and many more along the eastern seaboard, but they're not plots that we actually control. So just want to call that out. All right, next slide, please. This is an example of the data that we get back. And I'm not here to lecture you about all these different inbreds, et cetera, but I think it's kind of an interesting way to think about it. So this is the earliest maturity range that we tested last summer. It was from about 80 to 94 day. And in here, there's a bunch of experimentals that no one has ever seen before. And then there are some commercial checks and some Viking hybrids that we have in there as high yield testers. And there's a couple of things I want to call out. So the first highlighted row has a 3 in front of it, and it's 164-005 crossed with a current inbred that we license in. So this is 164 is an inbred that we have control over. We're crossing this with an inbred that we can license from another company and producing a hybrid that is very competitively yield. It's not blowing everything away, but it's competitively yielding, and it's also very good standing, has some interesting things about it. We're probably going to put that into level 200 testing the next year to take another look at it. Whether or not it actually makes it, based on this data, you'd say no, it's not raising the bar enough, but this is just a small number of locations. It's a screening trial. Another one to look at is the next one down it has about halfway down the page. There's one that's highlighted. It has a 16 in front of it. And there you see 164-005, and it's crossed with a different current inbred that we license in. And this hybrid was the highest yielding hybrid in the trial. Really high yields, but terrible stock lodging. And so that's why we have these trials, right? To identify the hybrids that are the best yielding, yeah, but we also need to know that they have good stalks, they have good roots, they don't have green snap, they don't have silk jamming, they don't have other things that would rule them out as a commercial hybrid. And so that's just a good example. It's also kind of interesting if you look real closely, the two hybrids I just talked about have the same female parent. So when we cross it with the one inbred that we licensed in, it actually stands pretty well, where we cross it with a different inbred and then it has lodging issues, right? So that's something we're keeping an eye on. The last thing I'll talk about isn't highlighted in green, it's highlighted in blue at the bottom. And that's a modified parent that we have access to use. Actually, it's an in-licensed inbred, and we crossed it with an off-patent inbred that we're interested in because of the grain quality that it brings. And so you see it's a competitively yielding hybrid, has very good stalks and roots. And if you look at that, the dark blue box there, that's the test weight, and it's about 2 pounds heavier than most of the hybrids around it. And that's very intriguing to us, right? We would love to be able to bring in a 95-day food grade corn. And I'm not saying that's going to be the one. I'm just saying this is the kind of thing we're looking for in our testing. Next slide, please. All right. So yeah, I think this is close to my last slide. That again is a shot of a research plot that was being taken out last fall. That's one of our combines out there taking the plot out. So it's randomized replicated testing. It's 4-row testing. Each row is, I think, usually 17.6 feet, and it's replicated 3 times throughout the field. So in addition to the corn breeding work we're doing, and in the product development work that we're doing, and the picture we're looking at there is not corn breeding, right? That's product development, where we're figuring out yields and lodging and all those kinds of things that matter to farmers. We're also planning on leveraging this research arm to do some new things. One of them is the biologicals testing. We've been doing biologicals testing as Lea Seed for the last on and off for the last 6 or 8 years, where we've tested new seed coatings that we are interested in that we thought would help our customers. But it's never been with our own research capacity, and it's always been somewhat limited in scope. And with this new research arm that we have, we're going to expand this biologicals testing to really take a leadership role in trying to identify the best available biologicals specifically for organic farmers. So if you could have the next slide, please. So this is a slide that Aaron Silva shared. I was at the American Seed Trade Association meeting in December, Aaron Silva was there presenting to the Organic Seed Committee, and I'm not going to try to explain this slide too much because I'm not a scientist, but this was what they call a meta study where they group together a whole bunch of studies from around the world and look at all the biologicals that are available and look at their effects on different growing characteristics. So if you look on the left-hand, like just take the bacterial group on the top, you'll see that first part says SG, and that's seed germination, and then there's an SE, that's seedling emergence. PB is plant biomass, DC is disease control, and CY is crop yield. And then in that little box, they have the different. They explain what the different colors mean. And I think for me personally, because this is something I've been looking for since about 2003, the thing that I'm the most excited about is the SE, and that's the seedling emergence, right? And you can see that there are some active biologicals that have a really significant impact on seedling emergence. They're named there. If you're a scientist, you understand what those different species are. I'm not. But the overall message here is, hey, these things actually work and have a pretty significant effect on seedling emergence. And I think most organic farmers are going to be pretty excited about that. I know Erin Silva in her talk, she said when she first started doing some background research into biologicals, she was very skeptical, as a lot of us are, including me, because we've been promised so much by biologicals and haven't really seen consistent outcomes with them, right? So we've seen a lot of, yeah, it works sometimes, yeah, it doesn't work sometimes. But what we're seeing here, especially with the newer classes of biologicals that are being developed, there's some really significant impact. So we're excited to work on this project. Fortunately, it's very easy because there's only a few companies involved. Can I have the next slide? That was a laugh line. I can't tell if you're laughing or not, but these these are the hundreds of companies that are out there developing biologicals to be used in different ways in uh, agriculture. And you can see there's different groups of them. There's biopesticides, there's stimulants, there's inoculants, which we've used for 40 years, 50 years, fertilizers, growth regulators, etc. And then there's something called semiochemicals, and I have zero idea what that means. But the part that we're mostly interested in as a company are looking at the biostimulants, the microbials, and eventually the biofertilizers. We've been looking at inoculants for a while, and possibly some of the biopesticides, and I'll talk a little more about that. So our goal, we're not going to be developing any products, right? Our goal is to make relationships with the most important ones of these companies. And there's some big ones in here, as big as Corteva, et cetera. And there's some small ones. And it doesn't, just because they're big doesn't mean they have the best product. Some of the small companies have good products too. But to identify the products that really are going to be the most beneficial for organic farmers. Could I have the next slide, please? This is that picture, by the way, is a plot that we had in last summer on an organic farm in northern Iowa. We were testing out, I think, I can't remember, it was 8 or 6 biologicals, and looking at it, and that was a, we've been doing work like this for a while, but now we're going to be able to do it at a broader scale. And fortunately, our new president and CEO, Brett Bell, has good relationships throughout the industry, knows a lot of the folks in this space already. And so we're going to have a leg up on screening out companies to work with. And then we're going to do lab testing, we're going to do greenhouse testing, and then we're going to do in-field testing to identify the biologicals that are most useful as seed-applied biologicals. And I want to be clear, long-term, we're also very interested in being in adding value by being a trusted advisor on biologicals that aren't necessarily seed-applied. So these would be over-the-top biologicals that farmers could use to control, say, crown rust in oats or fusarium head blight in wheat, right? But we want to, again, focus our research and start small with things that we can afford to do. So we're really going to focus on the seed-applied biologicals. Obviously, the first thing we're going to look at is emergence, right? So we need to get the corn out of the ground. And it's not just corn; it's other species we sell, but that is the primary area of focus immediately. Uniformity of stand matters a lot, and that has to do with emergence, but it also just has to do with some of the biopesticide things we talked about already. Seedling disease prevention, right? There are there are already products that are licensed and in the marketplace that have actual disease control. We strip trialed one last summer called Ultim, which has pretty good control of Pythium. And we were impressed with the product. Unfortunately, it's OMRI approved with a restricted label, meaning you have to get permission from your certifier to use it. And that's one of our things. One of the values we can provide here is, since we do understand the needs of organic farmers and we do understand organic certification, we can provide value to some of these companies in the biological space by helping them understand what OMRI approval means, what it means when something is OMRI approved with restriction, et cetera. So we can provide some value back to the folks that we're working with in this biological space. I'll talk about placement just a little bit. So as I mentioned before, one of the disappointing things about biologicals in the past is that we don't always know where they work and when they work. And so sometimes farmers use them and they make a big difference. Sometimes they use them and nothing happens. And so one of our goals is to really to begin to get our arms around what are the factors that make a particular biological really show a difference versus not, so that farmers know when it makes economic sense to invest in a biological, right? So if you don't need to use it, let's not spend the money to use it. And then the last bullet point there is to prevent unintended consequences. So the unintended consequences can be many different things, right? They could be flowability issues. One of my worst years in my career was the year that we launched a new biological on our organic seed corn called Resid HC, which came from a company in Spain that eventually got bought by Corteva. And the Resid HC actually had great efficacy. It was a good biological in terms of its ability to help corn get out of the ground and protect the seedling, but it was like we had coated the seed with sandpaper, and it wouldn't flow out of a planter, and it was just really a problem for some of our customers. And probably, honestly, my most stressful year in the seed business was working out from underneath that and helping farmers get adequately compensated for the loss that they had that year. So I'm not going to live through that one again, and we're going to make sure that all the biologicals that we launch have really good flowability. We're also concerned with seed safety, which is a normal thing that you want to test for to make sure that the biological you're putting on the seed does not have any negative consequences for the seed. Maybe it doesn't show up in year 1, but it might show up in year 2. So we want to be testing for that. And then obviously it's not on this slide, but baked into all of this is we need to make sure that we have clear path for organic farmers to use anything that we launch, that it's OMRI approved. And if it is OMRI approved with restrictions, that we understand what those restrictions are and that we only offer that product as either a planter box treatment or perhaps a custom treatment. So that's one of the things that we're going to utilize this research arm to do, is just to work through these biologicals. And I think I'll stop with that one. Do I have one more slide? Yeah, I just wanted to say again, thank you all so much for coming. It's a picture that I took, actually not this year, I took it a few years back, but I could have taken it, I think, yesterday at some really nice sun dogs in front of my house. So thanks again for coming. Stay warm, and I'm going to stop here. If there are any questions, any more questions, Ty, I can take those now. Otherwise, we can have a short break before the next speaker.
All right. Yeah, let's give them some time to come here. Just one thing here, quick, while people start to think of some questions here. How soon can you expect we can see these new hybrids coming out from this joint venture?
Yeah, good question. So again, this program has been in operation for 20 years. We invested in it last August, but it's been up and running for 20 years. In fact, we already are selling some hybrids that contain inbreds from this program. So it's here right now. Our goal, one thing I kind of touched on, I'm going to just emphasize it again. Our goal is not to have 100% of our corn come out of this program. We want to be providing the best hybrids to our customers. We believe that, and we know that based on past experience, we can do that. We can achieve that with some hybrids by making some internal crosses or by taking inbreds from this program and crossing them with inbreds that are available to us to license in. So we're going to keep ourselves honest. We're only going to launch products that we believe are a step forward for our customers, and some of them are going to be coming out of this program. I can't tell you how many, but we already have some that we're using.
All right, thank you. Yeah, no, thanks for the great info here and everything, and I'm sure everyone's appreciative of this next venture that RWC is taking on, and looking forward to what's going to come from it. So,
Right. Thanks, Ty.
And one quick question before I
Yep.
just snuck in here. What biologicals are you testing?
Ooh, so we're continuing to test. I mean, there, as I mentioned and showed on the slide, there are literally hundreds available, probably for seed coating. At this point, there's probably more in the realm of 20 or 30 that we're interested in, and they could run from an actual just a mineral, which is like the Ultim ST is really just copper hydroxide, right? It could be a microbial, could be a bacterial, and there are sometimes they're just a spore form of a of a fungal organism, like we currently put on our corn, the Saber-X, which is a trichodermal blend. And then there are other things out there as well, which are isolates from plants, like the very popular one, which is becoming OMRI approved, is called Heads Up, and Heads Up is just an isolate from quinoa, believe it or not. And it's been used on conventional seed for quite a while by some big companies, and that's becoming available for organic farmers as well. So it runs the gamut across all those different kinds of, whether they're actually active biologicals like a bacterial or an inert substance like copper hydroxide, or it could be all those different things.